Yes, this is the steady state analysis. Let me before going to the type is the, I mean, there is initial they will ask two questions. One is the order. Order is different from type number. What is the order of a system? What is the type number of a system? The order means it is dealing with the closed loop transfer function. Order is dealing with the closed loop transfer function. That is g of s divided by 1 plus g of s h of s. Listen, order means, what is the definition of order? Order means highest power of s in the denominator of a closed loop transfer function. The highest power of s present in the denominator of a closed loop transfer function is called order. For example, assume a closed loop transfer function equal to s plus 3 divided by s into s plus 2. What is the order? Highest power of s present in a denominator transfer function. 2. If you multiply s with, if you send this s inside, highest power of s, I'm asking, highest power. Multiply, if you send this s to inside, s square plus 2s. Highest power of s means s square. So 2 is the order. So order is always dealing with the closed loop transfer function. Very, very important. Other than gate also. Any competitive exam, they will ask what is the order of a system. We studied a second order system, s square plus 2 zeta omega n plus omega n square. S square, that's the first second order system. Next, what is a type number? I'll write it here. Let me write it here. The type number for type number of a system, we require a loop. Let me write loop transfer function. That means loop transfer function means g of s, h of s. Type is always dealing with the loop transfer function. Order is always dealing with the closed loop transfer function. So now we'll discuss what is a type. Type means assume, for example, assume g of s, h of s is equal to s plus 3 divided by, let me define here. I will define type number. I will take the same example. Type. The type is always dealing with loop transfer function. I want loop transfer function, not closed loop transfer function. I want loop transfer function g into h, just multiply g into h. They will give g of s, open loop transfer function. They will give feedback path gain. If you multiply, you will get a, assume this is I got. So what is the type number means? Listen, type is different from order. Type number means the number of poles at origin is called type number. Number of poles at origin. Check it. If you draw the pole zero plot for this one, s equal to 0, equal the denominator to 0, s equal to 0, s equal to minus 2. This is the pole. But number of poles at origin is nothing but a type number. So it is a type 1 system. Next, we take second example. G of s, h of s equal to s plus 3 divided by s plus 2. In this case, if you draw the pole zero plot, s equal to minus 2 is the only one pole, but there is no pole at the origin. So it is a type 0 system. Number of poles at origin is 0. So type 0 system. If you take third example, g of s, h of s equal to, for example, s plus 3 divided by s cube, s plus 2. This is the type 3 system because number of poles at origin is 3. Only s power, number of poles at origin, s power 2, s power 3, s power n. S power n. It is a type n system. Suppose one more example. It is sometimes they will ask me exams. G of s, h of s equal to s plus 10 divided by s square, 2s, 2s square plus s. What is the type number now? Anybody can answer? What is the type number? In this example, what is the type number? Anybody can respond? 3. Why? Because it is don't also say s square. Already s is there. they sent one s inside. Take that s outside, s plus 10 divided by s cube into 2s plus 1, number of poles at origin. Why we need to study this type of a system is, I will explain. This type of a system is dealing with a steady state error. The type number will affect the steady state error, how much error between input and output. If type 0, what is the error? If it is a type 1, what is the error? If it is a type 2, what is the error? Okay now. Okay, let me erase. Okay, in general, if it is a type of a system is, I require a loop transfer function. Check it out. The open loop transfer function of a unity feedback system can be written in two standard form. That means G of s, H of s. Open loop means they given G. What about H? Unity feedback. G of s, H of s, the same thing you will get. First one is, in general, transfer function is, numerator is called zeros, denominator is called pole. Yes or no? This K is a DC gain. K is system gain or DC gain. S plus Z1 is 0. S plus Z, why I am taking Z? Otherwise, you can take a K into S plus A, S plus A1, S plus A2, S plus A3 in the numerator, divided by S power n into, you can take S plus B1, S plus B2, whatever notation you want, you can use. To understand the concept, they use Z1, Z2, Z3 like that. P1, P2, P3, because it is a pole, it is a zeros. If it is like this, that means S plus something, S plus something, this is called pole zero form. Okay, it is not required. Just to understand the concept, it is not a by heart, it is not required. Just a loop transfer function is, it is a G of s, H of s. K is a DC gain. S power n, this n is called a type number. It is a pole zero form. What about the time constant form? Time constant form is, if you make a Z1 outside, Z2 outside, then it is a 1 plus, 1 plus. If you take P1 outside, 1 plus. If you take P2 outside, then 1 plus. So that means the time constant form is, it will be like this one. You can use this one or you can use this one. It is correct now, check it out. Time constant is 1 plus something, 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 1 plus. Pole zero plot means S plus something. That means in this case Z1, if you may come outside, take Z2 outside, then you get 1 plus, 1 plus, 1 plus. Instead of taking this is the K, because to make the difference between pole zero form, time constant form, if you take Z1, Z2 outside, P1, P2 outside, then K will become K2, K dash. That means it is a constant. If you multiply K with Z1, Z2, P1, P2, you will get some other constant, K dash and go to. Otherwise, if you take any textbook, they will give the loop transfer function. Loop transfer function G of s, H of s is equal to, in general notation, is equal to 1 plus s into tau 1, 1 plus s into tau 2, 1 plus s into tau 3, like that, numerator, over s power n. N is type number into 1 plus s into tau a, 1 plus s into tau b, like that. This is called a time constant form. Time constant form, because 1 plus numerator, then also 1 plus 1 plus. In exam, they won't ask whether given as a time constant form or a pole zero form. Just we have to know, to find the type number, I want a loop transfer function. That's all. That is a concept. Okay, next we'll see. So if it is a type 0, the denominator s power 0. This is n is called, check it out. This n is called type number. If n equal to 0, s power 0. S power 0 means that value will become 1. That's why if it is a denominator, I'm talking denominator only, s number of poles at origin. In this case, no poles at origin. That's what is called type 0 system. If it is a type 1 system, I'm not concentrating numerator, just s for number of poles at origin, only 1, s power 1. Check it out. It is zoom, S power. Type 2 means S square, number of poles at origin in time constant form. 1 plus 1 plus 1 plus 1 plus. You don't bother about Z1 into T. Now it is general 1 by Z1. You don't bother about the multiplication of S here. Don't bother about multiplication S. It will not play any role. Just I want a K value, number of poles at origin. Okay, this is a type 0, type 1, type 2. Why I am studying type Z, type of a system is it deals with the steady state error. Okay, before going to the steady state error, let me see the derivation part. The derivation part is not required. This entire derivation part is not required, but I will explain how I am getting that one for some students. Check it out. This is the E of S. E of S is the output of a summing point. E of S is, let me use this E of S is, this E of S is equal to R of S coming towards summing point with symbol plus. R of S. This is the negative feedback. Let us assume I'm going to use a negative feedback. I'm going to use a negative feedback. If it is a negative feedback, then towards summing point B is coming with a negative symbol. So this is minus B of S. First one. And the second one, let me take a C of S. C of S. Otherwise, B of S. This is the B of S is the output of this feedback part. Now, from this one, from the diagram, B of S is equal to, check it out, B of S is nothing but C of S coming towards this feedback. C of S is multiplied with the H of S. So B of S is nothing but C of S into H of S. Next one, I'm going to check it out. What about the C of S? C of S is the output of, see, in this point also C of S, here also C of S. C of S is nothing but E of S is multiplied with G of S, that is given by C of S. So C of S is equal to E of S into G of S. Check it out. I'm going to write again. So replace B of S is here. Replace B of S value, then E of S equal to R of S minus B of S means C of S into H of S. C of S into H of S. Again, I'm replacing that C of S. I want error. That's I'm replacing this because here also it is a error. I don't want the CF. I'm not going to find the transfer function. I'm going to find the error signal E of S. That's why I'm going to replace C of S as a E of S into G. So E of S into G of S, already H of S is there. Then it is a E of S, it is also E of S. Bring a E of S to one side, then you will get E of S plus E of S into G of S, H of S is equal to R of S. Make E of S as a common factor, then E of S equal to, E of S into 1 plus G of S, H of S, that equal to R of S. But I want error signal Laplace is equal to R of S divided by, if it is a negative, 1 plus, if it is a positive, 1 minus G of S into H of S. This is the derivation part they are given. This is the E of S. This is the derivation. If it is a negative symbol, you will get positive. If it is a positive feedback, you will get negative. That is the difference. So error signal. Check it out. This error means difference between input and output. Error signal is, let me use a different color. This error signal, this E of S is function of first reference input. E of S is depends upon reference input. Second one, E of S is depends upon loop transfer function. That is G of S, H of S. If it is a type 0 system or type 1 system, type 2 system, type 3 system, then error will affect. That means E of S will depends upon this E of S. This E of S will depends upon loop transfer function, and E of S depends upon type of input. That error is a finite, or that error is a 0, or that error is a infinity. That is depends upon the input, what type of input you are giving to your system. Not only that,